Hello YouTube, my name is Manasse, and today I'll be answering to some questions to explain switching concepts in networking. So without further ado, let's dive into the video. The first question is, what is layer 2 switching? Layer 2 switching is a process within computer networking where data is forwarded at the data link layer, which is layer 2 of the OSI. Now, layer 2 switching is responsible for transferring data between adjacent network nodes in a wide area network or between nodes on the same local area network. In the process, MAC addresses are used to decide where to forward the frames. If the destination MAC address is in the table, the switch will forward the frame out of the specified port. But if the destination MAC address is not in the table, the switch will forward the frame out all ports except the incoming port. How are switch decisions made? When a switch receives a data frame, it examines the destination MAC address in the frame's header. Switches maintain a MAC address table, also known as a forwarding table or content addressable memory (CAM) table. The content addressable memory maps MAC addresses to the physical ports on the switch where devices are connected. The layer 2 switch decision making is made in two steps. The first step is the learning step. The second step is the forwarding step. In the learning step, when a switch receives a frame for the first time, it records the source MAC address of the frame and the port on which it arrived in its MAC address table. This process is known as MAC address learning. So this is the learning step. If the source MAC address is already in the table, the switch updates the timestamp associated with that entry. Now, in the forwarding steps, when a switch receives a frame with a destination MAC address, it looks up to the destination MAC address in its MAC address table. If the destination MAC address is found in the table, the switch then forwards the frame only to the port associated with the MAC address. This is called unicast forwarding. Moving forward to the next question. What is VLAN? VLAN means Virtual Local Area Network. VLAN is a logical grouping of devices within a network, even if they are not physically located in the same local area network segment. VLANs are used to segment network traffic, improve network performance, and enhance security by isolating groups of devices from each other. Why can two devices on different VLANs communicate? The main reason two devices on different VLANs can communicate directly is that VLANs are designed to isolate traffic between different groups of devices for security performance reason. And each VLAN operates as a separate broadcast domain, meaning broadcast traffic, such as ARP request or DHCP request, is contained within the VLAN and not forwarded to devices in other VLANs. And devices on different VLANs typically use different network subnets, which means they won't be able to communicate at the IP level without some form of routing. Now, what is the solution? One solution to enable communication between devices on different VLANs is to use a technique called router on a stick. In that technique called router on a stick, a router with multiple virtual interfaces configured on a single physical interface is used to route traffic between VLANs. Each sub-interface on the router is configured with an IP address corresponding to a different VLAN subnet. The router acts as the gateway for each VLAN, allowing communication between VLANs by routing traffic between them. Here are the steps briefly. Configure VLANs on the switch, configure trunking, configure sub-interfaces on the router, and then enable routing. What is Layer 3 switching? Layer 3 switching combines the capabilities of traditional Layer 2 switching with the Layer 3 routing. In Layer 3 switching, devices called Layer 3 switches are capable of both switching frames at layer 2 based on MAC addresses and routing packets at layer 3 based on IP addresses. When a switch needs to make a path decision between VLANs, in a layer 3 switching environment, it follows a similar process to a traditional router. The first thing is routing decision. When a layer 3 switch receives a packet from one VLAN destined for another VLAN, it examines the destination IP address of the packet to determine the destination subnet. The next thing is routing table lookup. The layer 3 switch looks up the destination IP address in its routing table to determine the best path to reach the destination subnet. This routing table contains entries that specify which interface or next hop router to use to reach different network subnets. And then we move to forwarding. Based on the routing table lookup, the layer 3 switch forwards the packet to the appropriate interface or next hop router. If the destination subnet is directly connected to one of the switch's interfaces, it forwards the packet directly to the interface. If not, it forwards the packet to the next hop router specified in the routing table entry. Before forwarding the packet, the layer 3 switch adds VLAN tags to the Ethernet frame to indicate the VLAN membership of the packet. This ensures that the packet remains associated with the correct VLAN as it traverses the network. How are switching decisions made? Once the packet has been routed to the correct outgoing interface, the layer 3 switch switches the packet at layer 2 based on the MAC address of the next hop device or router. This involves updating the layer 2 header of the Ethernet frame with the MAC address of the next hop device and forwarding the frame out of the appropriate interface. By combining layer 2 switching with layer 3 routing capabilities, layer 3 switches are able to perform inter-VLAN routing efficiently within the switch hardware, offering high-speed routing between VLANs without the need for external routers. This improves network performance and scalability in environments with multiple VLANs.